In this video, we're going to talk about ratios and proportions. So we'll start with ratios. What is a ratio? Well, a ratio just compares two things. So a ratio uses division to compare two quantities. And the ratio of two quantities, A to B, where B is not equal to 0, can be written in three ways. So we write ratios in three different ways. We can write them using the word to, A to B. You can write them with this colon, A to B, or the ratio of A to B. Or what's most useful in math for us is writing them using this fraction, A over B. All of these statements are read the same way. They all mean the same thing. So we can write them any way that makes kind of most sense in the situation, or just the way you're asked to write them. But they should always be written in simplest form. Sorry, let's just scratch it out there. So they should always be written in simplest form. So always reduce the fraction, in other words. But it's very helpful in math, or it will be very helpful if you can just recognize that anytime you're comparing things, you can write it as a ratio. So let's look at this example. At a car wash fundraiser, 18 ninth grade students and 14 10th grade students worked the first shift. So find the ratio of 9th grade students to 10th grade students. So there's 18 9th and then 14 10th. So if I want to compare, and I'm going to write this as a fraction, 9th over 10th, then there's 18 9th graders over 14 10th graders. So that's a ratio. That can be very useful. We can also reduce that. As if we divide by 2, then it's 9 over 7, so 9 to 7. And then also you could write this as 9 to 7 or 9 colon 7. Go ahead and try part B. Part B says the ratio of 9th grade students to all students. So you want to compare 9th and all. And so one thing that's helpful to kind of start to think about is you want to be aware of what's on top and what's on bottom, like what category is on top, what type is on top, whatever the situation is. So on top, we're putting the 9th grade students. So that's, easy. We just have, it tells us 18 ninth. And then on bottom, we're putting all the students. So we got to add these together. So 18 and 14 is 32. So we have 32 students there. Let's see, if we divide by 2, that's 9 over 16 when we reduce. And so this is probably the best way to write it, really, because it's a fraction. It's useful for proportions that we'll do next. But we also can say 9 to 16 or 9 16. That means for every, it's talking about another interpretation of this. For every 9 9th grade students there are 16 total students. Okay, so then the next question is, well, what is a proportion? And a proportion, just let me see if I put this on the next page or they're not. Okay, so a proportion just compares two ratios, or sets two ratios equal to each other. I feel like it's pretty common to use proportion and ratio interchangeably, like they're the same thing, but they're not. Like this is a ratio, just 9 over 16. But if we have two ratios set equal to each other, then we have a proportion. And a proportion is very helpful for finding unknown values. Okay, so let's look at these are all proportions here. And we're going to solve these. So notice that this is a ratio equal to a ratio, proportion. The way to solve these is we have this nice little shortcut, which is to cross multiply. And I'm not a fan of many shortcuts in math, but this is one I really think is useful and important to learn. And so when you cross multiply, what you're doing is just getting W by itself. So you're multiplying both sides by 35, and then you're multiplying both sides by 7. So you're going to get rid of the fractions, basically. So what's going to happen is, and you can kind of illustrate this a couple different ways, but if you do 7 times W, and let's just bring it straight down here. So that's 7W, and then 4 times 35. I'm going to grab a calculator, make sure I don't mess that up. And so that's 140. And so you we call it cross multiply because you multiply across. So multiply I did there, drop it straight down, multiply there, and just drop it straight down. Now the order doesn't matter here. If you prefer to put the 7W in on the left and the 140 on the right, that is fine. And then you can just solve for W however you need to. So in this case, divide by 7 on both sides, and you get W is equal to 20. And you can plug back in and make sure that makes sense. One quick way to check, just to make sure like you didn't make a kind of a common error, is look at the number for the known ratio. So the smaller number is on top, the bigger number is on bottom. So over here, it should follow the same pattern. It should be a smaller number over a bigger number. And so we can see that's true. So that's 20. Another pattern, which is you might be able to see, is just like the multiplication will hold. So if we look at the relationship across, so 7 and 35, if I do 7 times 5, I get 35. If I do 4 times 5, the same number, I get 20. So there's a lot of patterns with these proportions, and it's useful to try to see those patterns. For instance, even here, if you can see that pattern, you could solve this one just by looking at it. 2 times 6 is 12. So then 9 times 6 is 54, so that's got to be your answer on this one. But let's cross multiply, as that's kind of a more advanced skill for you. So we'll cross multiply those, and you get 2m, so you drop that down, is equal to 108. And then divide by 2 to get m is equal to 54. Here, if you want to look for the pattern to just kind of see what it is, you can. 9 times 6 is 54. So 5 times 6, this has got to be 30. But let's cross multiply. And so 54 times 5 is 270. And then divide by 9 on both sides to get z is equal to 30. And once again, just make sure that the numbers kind of line up. So it's small number over big number is the pattern. So then you should have a small number over a big number. If you get a number for z that's bigger than 54, you did something wrong, and hopefully you can find your error. Where these become especially useful is through word problems. So let's look at a couple of these. It says a backpacker in the Sierras hikes 5.5 miles in 2 hours. If their hiking rate remains the same, how far will the backpacker hike in 7 hours? And then a hint, your equation should be in the form of a proportion. So let's figure out what we're comparing. We're going to compare 5.5 miles in hours. So we're going to compare miles over hours. So then you kind of know what's on top and what's on bottom. Now, if you wanted to do hours over miles, that would be fine. I think it's just more intuitive to go in order. So 5.5 miles over 2 hours. Okay, when you write proportions, all you need to do is make sure you keep the same pattern. So your pattern was miles on top, hours on bottom. Keep that same pattern. Okay, how far will the backpacker hike in 7 hours? Okay, well, 7 hours is time, or that goes on bottom. So let's just put that on bottom. And then we want to know how far he'll hike in 7 hours. And so let's make that x. And so if we want to, that's our variable. Let's write what it means. X is the distance hiked and 7 hours. But once again, think your mind needs to go back to comparing. What are you comparing? You're comparing miles and hours. So you're comparing miles and hours on the left side. We need to compare miles and hours on the right side. And then we can cross multiply. So when you multiply, you get 2x is equal to 38.5, and then divide by 2 to get x by itself, and you get 19.25 miles. Okay, and then make sure your answer makes sense. Over here, 5.5 is bigger than 2. So you want 19.25 to be bigger than 7. Okay, that checks out. You could also look across. If I do compare 2 and 7, this is kind of tricky because it doesn't go in evenly. But, it's more than 3. It's actually 3.5 times bigger. But it's more than 3 times bigger. And so if you just estimate this, more than 3 times bigger, well, if I did like 3 times 5, that'd be 15. So it's got to be bigger than 15 because I have 0.5. And so 19.25 does make sense. But really look for those patterns with this, which is tough to do. It'll take a lot of practice, but look for the patterns. Okay, this next example says, when 2 full moons appear in the same month, the second full moon is called a blue moon. On average, 2 blue moons occur every 5 years. Okay, so that's comparing 2 things. 2 moons, 5 years. Okay, so let's do blue moons over years. So we figured out what we're comparing. And then find the number of blue moons. So we want to know blue moons over 25 years. So 2 blue moons over 5 years is equal to X blue moons over 25 years. Okay, and then a good idea to label your variable. So X is the blue moons in 25 years. And then you can cross multiply. So 5 times X is 5X, and that's equal to 50. And so X is equal to 10. So we'll say 10 blue moons. Okay, now that we know 10, let's go back and try to find some patterns. So 5 and 25. Well, 5 times 5 is 25. 2 times 5 is 10. Okay, so that checks out. You can also just look and see that 2 over 5, 2 is smaller, 5 is bigger. If 10 is here, then 10 is smaller, and 25 is bigger. And then you also could even look at just reducing. So 10 over 25 reduces to 2 over 5 by dividing by 5.